Section 3.4, applications of set theory. So we're going to use different sets to model and solve real-world problems. So here we have Rachel. She surveyed grade 12 students about how they communicate with their friends over the past week. 60% called on a cell phone, 76% texted, 34 used social network, 56 called on a cell phone and texted, 18% called on a cell phone and used social networking site, 19% texted and used social networking site, and 12% used all three. What percent of the students used at least one of these three forms of communication? So what percent used at least one? Okay, so really what I'm asking is what's the number, I'm asking what's the number of A union B union C. I'm asking used at least one of these, or CTS. I should have done CTS, shouldn't I? Let's fix that. Number of cell phone, social networking, and texting. Okay, so how many, what percentage is included in there? And I would guess it'd be pretty high, right? If Rachel goes to a normal high school. So this Venn diagram represents the following set. C is cell phone, T is all the students who texted, and S is all the students who use social networking. So what does the universal set stand for? All the students. Record the percent used in all three forms first. So we're going to start in the middle, where we know all of them are. Okay, we know all that 12 used all three. Okay, now let's look at cell phones. Let's look at all the information that talked about cell phones. So it looks like there is, let's look at how many used both cell phones and texting. So cell phone and texted is 56%, but we've already used 12% there, so we have to take 56 off. We're going to put 44. Now let's look at cell phones and social networking. So cell phones and social networking is 18%, but we've already used 12, so there's just 6% here. Okay, let's do this last overlap here. Texting and social networking. Texting and social networking is 19, but we've already used 12, so we're going to put 7 there. Okay, and now cell phones, there's 66%. Well, 66, but we've already used 44, 12, and 6. So 44, 56, plus another 6 is 52. So that, is that right? Sorry, 56, and another 2 is 62. So then we need another 4 to get to 66. Okay, what about texting? 76%. Well, 76 minus 44 is going to be 32, minus 12 is 20, minus 7 is 13. Okay, and then we're going to have this last part right here. Okay, let's look at social networking. I have 34%, but I've already used 12% here. So 34 minus 12 is going to be 22, minus 6 is, this is hard math for Miss Callan, 16 minus 7 is 9. Okay, so we've filled out our entire diagram. Now we want to know the percentage of students who've used at least one. So what we're going to do is we're going to add up all of these numbers, because this would be everyone who's used at least one. And I'm going to grab a calculator because that's a lot of adding. So we have 4. See our entire diagram? We can. 4 and 44 and 6 and 12 and 13 and 7 and 9. There you go, 95%, which means there is 5% out here. So 95% have used. Okay, so that was one strategy we used where we actually filled out the diagram. Another strategy we could have used is a principle of inclusion and exclusion. So it says the number of A union B union C is equal to the number in A. So let's just change these letters so we are the same. Let's change this to CTS, CST, rather. C, S, T, C, S, C, T, S, T, and this would be C, S, T, C, S, T. So what this means is the union of all of them is equal to the number of cell phones, 66, plus the number of social network only, 34, plus the number of texts only, which is 76, minus those that cell phone and social, so minus 18, minus cell phone and text, 56, minus S and T, so that would be social network and text, it's 19, plus the ones that do all three, plus 12. And we're going to see that we're going to get the same answer as we did. So let's try this out. So 66 plus 34 plus 76 minus 18 minus 56 minus 19 plus 12. And lo and behold, we get 95. Okay, so that's one of the main principles we're going to look at. So just your key ideas. Set theory is useful for solving many problems. To represent three intersecting sets, use three intersecting circles. And it says, well, the intersection of A, B, and C is this region right here. The intersection of A and B is there, all those intersections. And then finally, you can use the principle of inclusion and exclusion to determine the number of elements in a set. Okay. You can use concepts related to sets to search for websites on the internet, put in exact phrases in quotation marks, connects words or phrases with and for containing both, or if you want either this or the other or both. So the word or is like union. So we could say the number in A or B or C, right? So I want to know, okay, if it's in either of those, I want them. So the internet kind of uses these sorts of principles. When solving a problem, it's often useful to visualize the problem. First, identify which sets are defined by the context. Then identify how the sets overlap. Finally, identify regions of the overlaps that are of interest to the puzzle or problem. It is often advisable to consider how much is known about each region, and then use the information about the region that is most known to deduce, remember deduction means using known facts, information about regions that are less well known. A systemic approach will result in answers that are easier to verify.